I'm sorry for this long, very long title. Reading it takes almost 19 minutes of my presentation. No, it's not real, but it's very simple. The idea it's a bunch of ideas I have been thinking in the last times, and as these ongoing ideas, I like also to discuss not also with myself alone, but with other people doing not only theoretical research, but also, sorry, empirical researches. And so these are dynamical ideas and things that are under my actual thinking. It's real thinking. It's not just a set of very well established ideas. In fact, I think that all my researchers are also using the same technique. In any case, my idea was to discuss about those kind of cognitive morphologies, and artificial or mixed or biological and artificial, which are cross-embodied, which are sharing different ways of bodies and different ways of thinking bodies, and then which challenges they are facing us. And therefore, I just want to make a summary about what I was trying to do. Usually, when we are talking about morphological computing and biological morphological computing, we are always thinking about the same thing. It's like a very common and normal bias, because it's like a common sense of thinking about bodies. It's the idea about that cognition, even socially distributed, whatever you want to think, it's performed by one body, not a set of bodies sharing information. So in that case, we can think that also exists some kind of similar approaches, like when we are talking about self-reconfiguring modular robots and that kind of approach. But it's not the same, because it's not cognitive approach based on how the body gets information. In that case, even in the case that we are working with context in which those robots, those machines are being changing at some point, because even in that case are thinking like the self body. So here the important thing is it's how we can use bio-inspired examples, but at the same time how it's necessary to go beyond biological capabilities. So thinking about how these kinds of new morphological computing systems could be reshaping constantly, and therefore requiring even the reshaping of the same cognitive process. So there is and despite there is a really interest on this kind of distributed cognitive systems, and we know that there is an interest about how flux things or swarm thinking is happening, or the existence of packs, coordination of schools, crowds, or societies. It's always the same. It's like a small unit that has the whole cognitive performance that is interacting with other, and then in the general process is produced the cognition. What I am really thinking is about what would happen if those morphologies would be at the same time constantly changing, and then would imply some kind of new necessity of integrating information. So it's important to think and to know that best powerful cognitive researches at this time come from the idea that the sensory motor intelligence emerges and allows the existence of more complex systems. If you want to see a review about these different morphological unconventional forms, I recommend you the paper of recent paper of Cordana, Morphological, Natural, Analog, and Other Unconventional Forms of Computing and Cognition for Cognition and Intelligence. It's very interesting to have a map about the real scenario in which these things are happening, and the combination of different kinds of cognitive approaches to this kind of fields. So my idea is, it would be really nice to start to think about this kind of entities, because it looks like the plausible future about robotic design. So one possible counter example about what I am saying, because it's this kind of thinking finds a very easy problem, or not a problem, but it's like a style of making research, is that at this very moment we have foundation models like BERT or GPT-3 that are very successful models that are achieving really incredible things, but at the same time they are not grounded on bodies. It's an approach that is much more centered into the intensive analysis of data. In that kind of models, they don't use embodied cognition, and they are even thinking that bodies are not necessary. And this is like a trend in contemporary AI research, to being focused into data, and or at this moment not just into the models of the data, but into the quality of the data, but not into the how those bodies process information, because data are data in relation to some kind of body, and this changes completely data. So at some point, some of these models, foundation models, are something like bio-inspired, but at the same time, they are at some point trying to make something like a reverse embodiment approach. It's something I have been thinking, because at some point they say, okay, we don't need to start thinking from sensory motor processes, but we can start just by using the symbolic, and then what we can do at some point is make the reverse process. We have the symbolic process, then we can integrate the sensory motor after the symbolic, and of course it works. All these things works, and the point is not if they are functionally plausible, because all of these models are plausible, and again, some of them are highly successful, but at the same time, they don't get the real idea about how natural entities think, and this bio-inspired thinking is very useful when you are trying to do new things, because it's the result of millions of years of evolution. So there are several technical and philosophical aspects related to this debate, because embodied versus disembodied AI. And this moment, OpenAI is abandoning robotics, and also the involvement of the motor system into the process of perception is nothing that it's necessary. Even at some kind of areas like artificial vision, these kind of approaches were excluded from the most important conference, like the conference on computer vision and pattern recognition. And so it's something like talking about artificial intelligence without robotics, talking about symbolic AI only, without the combination of grounded. It's something that grounded cognition is offering plenty of powerful solutions to daily and basic cognitive performance and activities. So how could we combine these kind of thinkings? And finally, this kind of combinations require the understanding about how morphology shapes conceptualization of concepts. It's like the concept of the stability of a system, of the dimension of a context, about what means the spatial coordinates in relation to the morphology of the system. It's nothing that is universal. It depends not only about the morphology, even about the thinking processes, about for example, the use of metaphors for understanding reality. So even about the process of seeing. There are also other kind of very interesting things in relation to this kind of crossing fields, and the combination about symbolic and grounded cognition, and also about changing grounded cognition, that is the possible combinations of things that we have already today, but that can be combined at some point in the future for producing new kind of entities. For example, we have at this moment the cloud robotics, in which we can make remote control about normal bodies or distributed bodies. We have swarm robotics, in which we can have social robots that are producing collaborative processes. We have modular robotics, and we have even hybrid artificial biological interfaces like biobots or humans with upgraded things. So these things are combined, can be combined for producing new kind of producing machines or informational systems. So one important thing, even if we only would be talking about robots, it's the transferability of about data processing across or among, sorry, robots and this kind of machines. But the problem is that this is not universal, and there are some labs in this moment that are working with and trying to do things like that. It's like to design physically grounded programming languages that describe a task and then can be compiled and translated to different architectures. That one kind of robot could be processing some kind of grounded process of acquiring information, and at the same time, this can be explained in some kind of universal translation platform that could be used by another robot. This is one special demanding task, and it's very important, for example, in contexts in which robots need to interact for doing things, but not interact in a very complex way, but in a very efficient way. So, and there are some kind of guys who are talking about that. And so the problem of this cross-embodied cognition is it's multiple. For example, one of the problems is that it's the foundation of multiple sensory motor intelligence, about how to create systems that are able to work from different sensory motor approaches and then sharing ideas. Because in most of cases, humans share the same sensory motor process and similar sensory motor mechanisms, and then translate to some kind of symbolic processes and even implement these kind of approaches to some kind of machines. And then it's simple because we are always using the same sensory motor platform for understanding the reality, but it could be changing for other machines. I have 4 minutes.
Jordi, just a second. Are you showing full screen? Because it's so small for me, at least.
Yeah, but I'm sharing the whole screen.
Okay.
It's not.
Okay.
It's not for you. It's not full screen.
No, it's so small
No.
that I cannot see the. Okay, never
Whoa.
mind.
Sorry, but I can change.
Okay.
It shows
Okay.
the full screen in a sense. I mean, there's nothing else to be seen, but it is rather small. Yes.
Yeah. The problem is I have a very big screen, and I don't know if the software is capturing. No. I because one day I decided that I was getting old, and gamers. It was just very stupid that young people using gaming devices had very huge and flat screens, and I bought a gaming screen. I have a very good screen, but perhaps the capturing is not good. Sorry so much. I don't know if I can change the sharing process and
Perhaps you can share your presentation afterwards so we can read.
Okay, I have no problem because all this data is for being shared. So one challenge is the multiple sensory design. Another one, the transferability and interoperability of these systems. Then the kind of bio-inspiration, not only human, but also a different kind of bio-inspiration, other kind of biological systems that at some point for some kind of processing can be useful. Bees, for example, or ants, or whatever, or even bacterial intelligence that is not so crazy, because some kind of specific problems may require different kinds of computing processes. And finally, the huge problem of the multimodality integration and translation, about how to integrate this kind of multimodal data into some kind of normal stream of data that must be used for taking some kind of solution. I suggest one possible example. It's a classic example, spatial exploration. It's a very demanding scenario because it's a context in which machines need to process data and then decide for actions without direct human control and supervision, because the distances are very huge, and then these machines need to take very autonomous processes. So long-term missions very far and without Earth remote control, and in which we could think, for example, into a modular robot that it's able, for example, to adapt to self-reprogramming, to self-repair processes, and then be much more adaptive. And it would be really also imply a challenge for the data integration of this model. It's not so complex, but it's something especially demanding. At the same time, how this modular robot would be really transferring this kind of knowledge to different operational robotic systems that would be there also working in a combined way. So one problem, I think, is that current modular robotics are not based on grounded AI, but on classic symbolic approaches. And this is not the best, I think, the best approach for exploring new ways of increasing complexity for these systems. And at the same time, complexity and efficiency, because the problem is not data, but good data and decisions about data. So I'm within the timetable. And thank you so much for your attention. I must say that I have been discussing some of these ideas with Yanis Aloimonos, and I think that part of his recent research is very interesting and is going in that direction. And I think that it's something very important, that to have highly theoretical models to think about cognition, at the same time make interactions, if possible, with people from engineering and computer sciences, because in that mean we are doing something like experimental philosophy or crossing disciplines researches. So thank you so much for being here, and I would like to discuss with you. And of course, I will share with all of you my presentation. No problem at all. Thank you so much.
Thank you very much, Jordi. Very, very interesting and inspiring talk, and looking forward to discuss with you.